Hey guys, welcome back to my 100 most popular algorithm series. In this particular problem, we are going to take a look at Leetcode problem number 102, binary tree level auto traversal. Again, a tree based problem. The problem statement is very simple. We're given a binary tree and we are required to do the level order traversal, which is from left to right, that is level by level. So in this particular example, we have three levels. At the first level there is a root element, so we'll do that traversal first and store it in a separate list. Then on the second level we have two elements which will store separately, and the last level will be stored separately. So every level will be stored separately and we need to traverse in that order, level by level, and at each level we need to traverse from left to right. Okay, so that is the problem statement. So here we are going to make use of queue. So the solution, let's quickly discuss how the solution will look like. So we'll have this queue which will track all the levels. Now the way it works is we will first put the root element here in the queue and we'll start our logic. So in every iteration we'll remember the size of the queue. So here right now the size of the queue is 1. We know the queue is one element. So which we know that single element at the current level there is only one element. Then we'll take one element out from the queue. I'll take 3 out for processing. Okay. Then I'll check out its left and right children, and then I'll push them in the queue. So here the left and right children are 9 and 20. So I'll push them in the queue. So I'll push 9 and 20, and this I'll add it in the current level. So I'm just adding 3 in the current level. Now as I mentioned, I had computed the size of the queue before starting this particular iteration, right? So I know there was only the size of the queue was only 1. So at this level there was only one element. So 3 is added at the first level. Okay, now I'll start my next iteration. Now in this iteration again I'll first mark the size of the queue, which is 2. So I know that there are 2 elements at this level, and then the logic is similar. So I take the first element out of the queue for processing. So 9 comes at this side. Then I'll check what are the children of 9. So there are none, so I'll do nothing. I'll just add 9 in the new level. Then 20 comes here. Then I'll pop 20 out of the queue and I'll check its children, which are 15 and 7. So I'll add them in the queue, 15 and 7, and I'll add 20 in the current level. Okay. Yeah, and the last one, so at this point I know that this level is also finished because I had computed the size earlier. So this level is finished, and then these 2 items will be added in the last level similarly. So they will be popped out one by one, and all its children, which are none, they are the leaf node, so there are no more children, so they will be taken out of the queue and added in the last level. So yeah, that's the high level logic that we are going to take. Fine. So let's begin the coding of this problem. So I'll first check if the root exists. If it doesn't exist, then I'll just return an empty output. Okay. Now as I mentioned, I need a queue. So Python provides the queue package. From queue package I'll pull out the queue class and I'll create the instance of the queue. Okay, just a little Python thing, but basically this queue is the queue instance that I'll be working with. Great. So the next task is, first I'll put root in the queue because that is my starting point. Okay, now I need a loop which will iterate for every level. So while queue is not empty, I'll iterate this, and I also need an output to store all the levels. This is the output outer array. Okay, so in every iteration, the first thing I need to do is compute the size of the level. So I'll do size equal to q dot. So this is the size of the current level. Now I know that if this whatever is the size, I need to pull out those many nodes from the queue and then add it in the current level in the output. So I also need something like current level. So every level, remember, every level is also an inner list. So I need something which will track the current level. Now while queue size doesn't get exhausted, we are going to just pull out one node from the queue. Alright, so we have pulled one node from the queue. Now we will add it in the current level. So its value will be added in the current level. Okay, so that part is done. Now what we need to do is we need to put its children in the queue, because they will be used in the next iteration, right? So if the left children is present, then I'll add it in the queue, and similarly if the right child is present, then I'll also add it in the queue. Okay, then I'll reduce the size. Yeah, so two things I'm doing. I'm adding the node in the current level, and I'm adding its children into the queue for the next iteration. Okay, so after this level is finished, we need to add this current level in the output. So I'll just add that in the output. Yeah, and at the end of when the queue becomes empty, we know that all the levels are traversed, so we'll just return the output back. Yeah, so that's the code that we need to write. Hopefully there are no compilation or logical issues. Let's verify our code. Oops, we have some syntax issues. Okay, my bad. From queue import queue. That's the correct syntax. Let me run this code again. Yeah, it worked. The output is very simple right now. Let's try with this. Oops. Okay. Yeah, there you go. It's working nice. Let me try with this final input. Yeah, it's working. So I'll submit my code. Yeah, it got accepted. So yeah, that's how you solve this problem. I hope you like this coding challenge. Stay tuned for more coding challenges like this. I'll see you in the next one. Bye.